requires QueueSocial to be authorized to publish posts to that user's account. So the user will need to connect all of their social media profiles to the application, and their authorization token will be stored on the server. Authorization tokens will never be exposed to the client-side application and will only be used in server-to-server communications, as it would be a massive security concern if someone were to fraudulently obtain the access token to a user's social media account. The front end for this application is a single-page application built with plain old React, so no server-side rendering or anything. The back end of the application is also built with JavaScript, specifically TypeScript, and it uses Express. This application will be used to fulfill both Category 1, Software Design and Engineering, and Category 3, Databases. For Category 2, which is Algorithms and Data Structures, I will refer to a separate project I built for my Algorithms class. Let's begin the code review by going over the existing functionality for QueueSocial. So far, we only have a landing page, a home page, and an unimplemented create post and link account page. The create post and link account pages will be completed for my enhancements. So this is the landing page. It just has a sign in and a sign up button. This app uses MongoDB for a database. I have that set up hosted on Atlas. And there are no collections. I reset the user's collection for this demonstration. So obviously if we try to sign in, there's no accounts. So first let's sign up a test user. And we are taken to the sign-in page, and let's ensure that that user was indeed created. So it was. We now have a test user. We can sign in. And we are taken to the home page. The create post page we can also view now. Before, if you're not logged in, these are protected routes. So we have here cookies, session cookies. This is handled by the cookie session npm package. It just uses JWTs to have secure sessions, and there's a route on the back end /auth/me, which just checks the login status. It views the cookies and verifies that the JWTs are valid so that the user can be granted access without needing to log in again. So now let's take a look at some of the code. It's just a regular React application. I created it using Vite. So we just have a source folder, and I chose to go with folder names for like each page has its own folder. So like the auth folder handles the login and the sign up, because these two forms are pretty much the same. So I wanted to just keep them all in one auth folder. Auth.css is pretty much the same between both of these pages. So just having those bundled together made a lot of sense. The create post page just has create post component and the CSS for that, along with this is actually just a component. Obviously footer's not a page. So I should probably create a components folder to keep stuff like that. Home navbar is a component. So a components folder with React components, and then these higher level directories are all pages, home page. And we have a custom hook here, use protected route. This just calls the /auth/me backend route to verify the user's login status. And if they're not logged in, we just navigate them to the login page. They won't be able to access protected pages. We also have a types folder and a lib folder. Lib just has like library functions, just like basically utility functions. Like this hook there's only one hook. I usually don't create a lot of hooks, so I didn't create like a special directory just for hooks. I just put it in the lib file, so that's fine. One thing about this code is it really has a lack of comments and documentation all around. So that's definitely something that needs to be improved. The check login, this is what actually makes the fetch call. The use protected route hook uses this. We have a login function to call the backend to log in the user. Logout function will clear the session. It's handled on the backend. And a sign up function also just calls the backend. We have some types. As of right now, only one type. That's another thing that's kind of lacking in this project. There should be a lot more types and type safety. And using TypeScript, that's really what it's meant for. So it could do a lot better here. We create some types for many more things. And the create post form. When you create a post, as of right now, it'll just be a text and an image, but you can add a bunch more fields to this interface to expand that form, like tags, or if you want to share a post within your post. I think like Facebook has that functionality, or if you want to like put a location on your post, a lot of social media platforms have that as well. I should say that for my enhancements, I'm only going for Facebook implementation. So this will just be a Facebook post scheduler, just to kind of keep the scope small enough to actually be able to complete it within this course. And then other social media platforms can be extended upon. So that's something to think about when writing the code as well. Not everything should be catered specifically towards Facebook. It needs to be created for extensibility, because other social media platforms should be added in the future, like Twitter and Instagram, etc. So this is the landing page, app.tsx. Just has the sign in, sign out button. Index.css contains normalized. This is just like public domain CSS file that it fixes a lot of the default browser behaviors for like Internet Explorer and Brave, all the different types of browsers, so that there's a more consistent user experience across them. Also at the bottom of this file, I think I have some global styles that are universal to every page. And the styles for the app component, and then our main component just has yes, I put this into a components folder, so that needs to be fixed. Perfect. And it just has a browser router, the nav bar, and the footer, because that should be visible on every single page of the application, and the various routes that link to our component pages. So that's pretty much it for the front end. Let's take a look at the backend code now. Let's just make that smaller. So this was just created using Express, as I said. It uses Mongoose to connect to MongoDB. First, we have a config folder. Database.ts just contains a connectDB function that connects to our database using our MongoDB URI, which is again hosted on MongoDB Atlas. It's not locally hosted. .env, this will just parse our env file and export it as a JavaScript object, so that each file that needs to use the config, the .env, well, I won't have to import that and to get all those environment variables themselves. We can just import this config object. Makes it a little bit more convenient. So this is our auth controller class. It pretty much just contains all the login route, the sign up route, logout, check login status. So these are all the functions. So let's take a look at the login function first. Once again, no comments. I mean, could definitely use a lot more comments everywhere. So we just take a username and a password, verify that we were actually given that data. So that's good. And then wrap all this in a try catch block because we are doing database interactions, which might fail. So we try to find the user by their username and return 404 not found. If there is no user that exists with that password, if there is, we will validate their password using bcrypt. Bcrypt hashes the password, so we don't just store plain text passwords in our database, which is very poor security if that were the case. 401 unauthorized if the password does not match. And then we'll create a token for them to create their session. Once we log them in, we make sure the session exists, or the session object exists on the request. It always should. I don't know why it wouldn't, but just in case, put that there. Assign them a token, just contains their user ID. Sensitive information probably shouldn't be stored in the token if it's not necessary. So just the user ID is fine. And then we set that token on the request.session object so that that will be sent with each request to the backend. And then we can return the user here, success true. Just give them their username and email, sorry, so that the front end knows who the person is and can show their data on the front end, their non-sensitive data. Catch an error, console.log it. This is another thing that's pretty bad. I should probably be returning a helpful error message to the front end instead of just logging it here. It's not great. It could just fail silently, which could be quite annoying in the future if you're trying to debug this or you don't know what's going wrong. Oh, async, yes. So this is the sign up function, username, email, password. Make sure that we were actually sent all these in the request body. It's a bad request if we weren't sent those. Helpful error message. So this one is good. Database interactions wrapped in a try catch. User.create. This is the user model contains like a Facebook user ID and a Facebook user access token. This access token it's a bad name for a variable. It's actually a Facebook user or a Facebook user access token, because there's page access tokens, there's user access tokens. All that's in the Facebook API documentation. It's kind of complicated and confusing, so a better variable name here would be great. This needs to be changed in the actual model because this is what the database uses to store that, and the profile picture for the user. All that's just set to null because they don't have a Facebook page connected by default. When they sign up, they'll have to connect that in a separate step. So if the user was successfully created, 201 HTTP code for created, successfully registered. If you notice, I tried to keep this common, like a standard format for the data that's returned to the front end. I just have JSON with a data field, which is another JSON object, and every response should have a success field within that data field that tells us whether the operation that we tried to perform was successful or not. So that can be easily checked on the front end, which I do use that on the front end. So it makes things a little bit more convenient. If something went wrong, I just log it and return 500 with the actual error. So that's not bad. But again, no comments really in like this entire file. So it's like very not good. Logout function just will clear the session. Request.session equals null, so that just gets rid of the JWT, successfully sign them out. If something went wrong, just return that error message. Check login status. This is what we use to verify JWTs so that the user doesn't have to re-log in over and over again. So we get the session and the session token, make sure that that exists. If it doesn't, they're obviously not logged in. If it does exist, it still could be invalid. They could have just put a random token. So we have to actually verify that token using our JWT secret that's stored in the configs in the environment variables. This secret can't be accessible to the front end because it's what we use to verify our JWTs and make sure that this JWT was actually signed by our application. And it's not just some random JWT that was sent along. So verify that. This takes a callback function. So if we get an error, it might be null. So if the error exists, something went wrong. If not, we get some decoded data, which is a string or an object, or nothing if there was an error. So this decoded object should have a user ID field, but this isn't typed very well. Like decoded is just a string or an object, which an object could be anything according to JavaScript. So I have to cast this to any just to access the user ID, which I know should exist. But if it doesn't, then this could crash the server here. So that's not good. This should probably be wrapped in a try catch block or should be typed better. So request.userid equals decoded.id. So yeah, if this ID field doesn't exist on the decoded object, then that'll crash our server for sure. So definitely a vulnerability here. So moving on, Facebook controller is unimplemented. This is what will contain like a create post, a route, a create post function that is called by our front end, and like a Facebook login method. So the controller is actually the higher level class that the front end actually calls these routes, and it calls the controller. So we have a Facebook service that does some of the lower level interactions with the Facebook API, like Facebook login, and this callback function is called after the login. Facebook automatically calls this callback function because if you can see in this login function, we actually redirect to this URL. So if the Facebook servers actually handle the Facebook login, and then it will call our redirect URI here, which goes to our callback function. So we get the login code, get their Facebook pages, the ID, the access token, we just get all that, the Facebook profile picture, and then we can return all that to the front end if that was successful. If this fails, then there definitely needs to be better error handling here. If this login fails or gets declined by the user or anything like that. So as of right now, really only the happy routes are implemented, which things could go wrong, and that would be a pretty terrible user experience if something just broke and they had no idea why. So error handling definitely needs to be implemented here. Get Facebook page picture, create post function. So this actually looks good, but this is just our Facebook service, so it's not accessible to our front end yet. So we'll have to create a route that uses this to create a Facebook post and hook our front end up with our back end here to get that working. An app access token shouldn't be sent, shouldn't be exposed client side. This function has good documentation up here, the create post function. This is like pretty much almost copied and pasted from the Facebook API documentation, I believe. So I should probably link to that just to get more information on what's actually going on here, so that I don't have to dig through the large Facebook documentation, because there's quite a lot to that. So just give them the page here so that anyone can find that documentation very easily and see what I referred to when I created this function. Be very helpful to add. App access token, inspect an access token just to see like what the scopes are and everything, or who, which user this access token belongs to. Get user ID associated with an access token. That's what we use when we inspect an access token. Exchange the login code for an access token. So once the login was successful, we get a code, and that code we can exchange for an access token to get access to that user's Facebook pages and get the page access token. So again, this should probably link to some relevant Facebook API documentation. I believe this was found on manually building a login flow, I believe is what the page was called in the Facebook API documentation. So that should be linked here just to have something to refer to see how this was built. And get Facebook pages, user access token, user ID, and then we can get their pages. So the app.ts file here creates our Express app, and we use the JSON middleware and the URL encoded middleware. Good comments here, for once, few and far between for this code, but I always forget what this stuff does. But if we don't use this, then our backend won't be able to parse requests, parse JSON requests. And this content type is what I believe the browser uses for like default form submissions. So if you have a submit handler on an HTML form element and have like a post handler in that form, this is the content type that uses to send to your URL, whatever you put there. So we want to be able to parse form submissions. So we have that. Cookie session, this is what saves our JWTs. We have a cookie secret, name it HTTP only, same site strict, just some additional security there. Create a router, everything in our auth routes. Yeah, so we imported our auth routes here. I don't believe we've gone over that yet, but prefix that with auth. That's all the login stuff. And then the app router, so like the base router for the entire app, is prefixed with /API/ the version of the API. So v1 right now, or v0 even, probably should be. Our server just connects to our database and listens on the port that we set in our env file. Some types here. This is what the Facebook API responds with. when we ask for information about a Facebook page. And then this is another Facebook API response. When we log in, we will get an array of Facebook pages or an error. So our auth routes here, so we just create an auth router, a separate router, login, sign up, logout /me. We've gone over all that. The models here, we have a page model. Right now, I believe this just represents a Facebook page, but could theoretically represent any social media page in the future. So this will probably need to be extended or edited a bit. Not sure if I should create different documents or different models for each separate social media, but not something I have to worry about now, only worried about Facebook. So the schema, an ID, a name, a profile picture, and some users, an array of users. So each user has a user ID and an access token to that page, because each user needs their own access token. So the reason that I have an array of users here is because I'll only have to store the page once if multiple users, like if it's a business and they have multiple social media managers, I'll only have to store that page once, and then attached to that page, I can have user IDs that refer to different users, and each user needs their own access token. For the user, they have a Facebook ID, which is the ID of their Facebook profile, username, email, password, profile picture, access token. I believe I talked about this. This isn't a very good name. It's actually a Facebook user access token. And then these are the page access tokens. So it just links a page ID and an access token, and then it's an array of those because a user can have access to multiple Facebook pages. And the schema, just a copy of the interface up there, but in MongoDB terms with their types. This middleware, we have a function to verify a JWT token. May have gone over that, or this may be duplicated code. Yeah, so I should definitely extract that into a function so that I don't have all this duplicated code here. So verified token, yep, and that's it for this file. So we just verify and then we call next, because this is a middleware function. And for utils, a fetch JSON method, just so that I don't have to double await. I could just call fetch JSON once. So that is it for QueueSocial code review. Let's now review my code for the algorithms and data structures part of this course. Here we have my final project for CS300 algorithms and data structures. This project is a university course scheduler, so it takes in a CSV file with the course number, followed by the course name, followed by prerequisites to the course. So CS101 is a prerequisite to CS102, because in the line that defines CS102, we have CS101, and CS101 has no prerequisites. So this program will take in this CSV file. It currently loads it into a binary search tree and attempts to find a schedule that such that all the prerequisite courses are taken before requisite ones. It turns out that a binary search tree is not a great data structure for this task. as binary search trees have no way of detecting a cycle, and some courses can have multiple prerequisites, but in a binary search tree, each node has at most one parent. So I actually couldn't find a way to get this to work for every possible course input. So let's just look at an example of the program running now before any of my enhancements. So it prints the menu. First, you have to load the data structure, which is a binary search tree in the implementation. We can then print information about a course like CS102. So CS102, we can see its data structures. It has prerequisites CS101. So let's try to get a course schedule for this input. So this is the sample schedule that the program outputs. As you can see, it's incorrect because CS201 is listed before CS102, and before CS102 is listed before CS101. But this should all be reversed. So there's definitely some bugs here. It does not produce good output for inputs where some courses have multiple prerequisites. So we can hop into the code now and see that I first have a file header. Just specifying that the C++14 standard should be used. I should have probably put the date here, but just the author. Uses the standard namespace. I created a contains function for vectors just to check if an element is present within a vector. We have the course struct here, contains a number, a course name, and a pointer to a vector of pointers to courses, which is the prerequisites of the course. So it uses a shared pointer. So there can be multiple references to this pointer and a vector of shared pointers to courses, so that if a course is listed in the prerequisites of multiple different courses, which it definitely could be, we only have to make one pointer to that course. We don't have to hold multiple different copies of that. So we can share a pointer between multiple prerequisite vectors. So I just have a function to check if course 1 is a prerequisite of course 2. Decent comment here, just a pretty straightforward function. This struct course, this maybe should have a comment here explaining why I decided to go with shared pointers. As I just explained, here we have a data structure for a BST node, shared pointer to a course. So each node has a course, each node has a left and a right child, and a default constructor initializes the left and right to null, and then a parameterized constructor that takes in a course and creates a node and just sets the course to that course. The BST class, some private methods. The BST has a root, add node function, in order traversal, and delete subtree used to clean up in the deconstructor. Find related node. I am not sure what this function does, so that is an indication that I probably should have commented this much better, or put some better documentation here for this BST class. This definitely needs more comments. Find dependent course. and a constructor, a deconstructor, or a destructor, in order traversal, insert, search for a node, and get the root of this BST. So find a related node performs an in-order traversal of tree until finding a related node. A related node is a relationship between two nodes in which one node is a prerequisite of the other. Okay, so related nodes have some prerequisites in common, or they depend on each other in some way. So we will search recursively in the right or in the left. So add node, we take in a node, current node. So we'll start with the root. So this is recursive, and we'll take in a course, create the node, find a spot, add it. So here we're just, seems like we're comparing the course numbers here. So check if they're equal, or sorry, to check if one is greater than the other one. If one course number is less than the other, we put it to the left, it seems like. And if the course number is greater than, we will put that node in the right subtree somewhere. But if there are no related nodes, then we go through this, and if the related node is a prerequisite of the course that we're adding, we will put it to the right, and if the other way around, we put it to the left. In order traversal just does an recursive in order traversal. Probably should have some documentation for this function, and this function here as well. It has a function comment, but this code down here is kind of confusing. There's like multiple nested ifs here, and there should definitely be some comments explaining what all of this stuff does, because I tend to forget how strings are compared in C and C++. Like if it's 0, then they're equal. If it's less than 0, I think it's probably the course. This course that we called the method on is probably less than the course that we passed as an argument. It could be the other way around though, so there should definitely be some documentation here explaining the intent of this if statement. And all of this stuff definitely needs some higher level explanation, because it's not clearly obvious what is going on here without having to wrestle around and figure out what the code is doing. So in order traversal is pretty simple. A constructor and delete subtree, so we have to clear up our memory. It's good. A destructor, which just deletes the subtree, which is the root, so the entire tree. In order traversal, this is a public facing in order traversal, just calls our private in order traversal. And an insert just calls our add node, so we create the node and then we add it. Or we create the in order. Root is null pointer. Yes, because root. What is root? Is this supposed to be this dot root? Because there's no root in this scope at all. So that's confusing. Not sure what's going on there. This should definitely be checked. This code is a little fishy. Find a dependent course. So we find a related node and see if it has any dependents. Returns the dependent courses of a given course. In other words, courses that have the given course as a prerequisite. Okay. Interesting. We can search the BST, search it left, search it right. So if it's if the course number is greater than, so node null pointer, node course number, return the node. So if we found it, return it. If not, search left. See, this is just searching every node in the tree. It's not even checking if the course number is less than the current node. If it should be working like if the course number is less than, we search left. If it's greater than, we search right. But it's actually just searching through every single node, starting left first and then going to the right. So that's actually, yeah. So could not figure out a log and time search. Yeah, this is a linear time search here. So quite interesting that just a regular vector could be used to probably be a much simpler and better implementation for this. Load a file. Actually have some comments here, but they're not great. I think that in this function comment here, we should have like the structure that the file should have that this function is expecting, just so that people know how to structure their CSV file. And it doesn't actually say anywhere that it's supposed to be a CSV. We actually have to look down here and see that we're splitting by a comment or a comma to determine that it's probably a CSV file. So definitely should have some better documentation there. Get valid courses. What is a valid course? For each line in the file, if the size of the line, so if the line isn't empty, we add the 0th element of the line. Okay, so a vector, so it's a 2D vector of strings. So each line has a course number, a course name, and then prerequisites. So the 0th element will be the course number. And we add the course number to our valid courses. So valid courses will just be a vector of course numbers. And to get a course, we take in a pointer to a vector of courses, pointer to a vector of pointers to courses, and const, okay, course number, so just a linear search, load prerequisites, no comments in either of these functions, not great. This one especially, looks like there's quite a bit going on here. Like why is 3 used here? Why does the line size have to be at least 3? I know the answer, because the third element of the line will be the prerequisites, and we're loading the prerequisites, but that's not obvious. This should be not a magic number. And for I equals 2, again, another magic number. Should probably create a variable for that and add some nice comments, some documentation here saying what's going on and why this stuff is all happening. So next we load the courses. Sort by number of prerequisites so that courses with the most prerequisites are added to the BST first. Okay, what in the world was I thinking? This code is may have made perfect sense to me at the time, but a couple of years later, it does not make much sense at all. I don't know why I made these decisions. So I think the main point to take away here is that I need to add a lot more comments to the code that I write for other people reading it, or even for myself in the future. Load BST. I'll just add every node. Make unique BST for course and courses. Insert the course. Okay. Print our menu here. Okay, pretty self-explanatory. Get the file name, load the file, load the courses. Okay, so we load the courses, but we don't actually create the BST until the user tells us to. And case 3 here, this doesn't look great. This should definitely be a function. I'm not sure why this is just embedded right into our switch statement here. It's definitely too much nesting for my liking. We have 1, 2, 3, 4, 5, like 6 levels deep, 7 even because of the while statement up here, and 8 if you want to count the main function. So that's way too much nesting for my liking. This should be extracted into a function for sure. And that is the entire file. So for my enhancements, since a binary search tree is really not a good data structure for this, I've found that using a directed acyclic graph is a good data structure. And then I can use some topological sorting algorithms such as Kahn's algorithm. It's used for course sequencing, which is exactly what we're doing here. So should be a great data structure and algorithm for this use case. So this way, with a directed acyclic graph, we can have courses with multiple prerequisites and not break anything, unlike with a binary search tree. So this should be good. So that will be my course enhancement, and this has been my code review for my algorithms and data structures section.